Subject AC machines. Topic single phase transformers. Subtopics practical transformer with winding resistance and reactance. Already in previous class we learned about the ideal transformer transferring resistance from primary to secondary, secondary to primary. Here one side to another side. Objective: on completion of this period you would be able to understand real transformer with magnetic leakage reactance, transferring reactance from primary to secondary, secondary to primary. That means from one side of transformer to the other side of transformer. And also equivalent impedance of a transformer referred to either side. So here this is the duration. So practical transformers factors needs to be considered. The ideal transformer is not a sufficiently accurate model for all purpose. A better model should be include and also winding resistance also considered. These are all for practical transformers. And also another one is leakage fluxes also considered. Another one is effect of limited magnetic permeability of the core material and also core losses and stray capacitance due to the electrical coupling between windings. That means significant at high frequency. The leakage flux. The ideal transformer model assume that all flux generated by the primary winding links, all the turns of every winding, including itself. In practice, some flux traverse paths that takes it outside the windings. Not all of the flux produced by the primary current links the winding, but there is leakage of some flux into air surrounding the primary. Similarly, not all of the flux produced by the secondary current, that means load current, links the secondary. Rather, there is loss of flux due to leakage. These effects are modeled as leakage reactance in the equivalent circuit representation. Such flux is termed leakage flux and manifest itself as a self-inductance in series with the mutually coupled transformer windings. Such flux is termed leakage flux and manifests itself as self-inductance is in series with the mutually coupled transformer windings. Yes, see here. So this flux is in air. This flux is in air, not in the core. This flux is in the air. This flux is called leakage flux pi L. This flux is called leakage flux, this one. So here due to secondary current, the leakage flux is secondary leakage flux. Due to primary current, supply current, this flux is primary leakage flux and this flux is the main flux. This flux is useful flux, that is mutual flux, that means it is main flux. Magnetic leakage of transformer, here leakage results in energy being alternately stored in and discharged from the magnetic fields with each cycle of the power supply. It is not itself directly a source of power loss, but results in poor voltage regulation, causing the secondary voltage to fail to be directly proportional to primary, particularly under heavy load. So here a distribution transformer are therefore normally designed to have a very low leakage inductance. So very important. A distribution transformer are therefore normally designed due to very low leakage inductance. So the leakage flux, this leakage flux at primary side, leakage flux is denoted by reactance, and this secondary flux, leakage flux is denoted by the reactance at secondary side. So here the practical transformer with winding leakage reactances are shown in figure. Here, the writing the KVL equations for the primary and the secondary loops, E1 is equal to V1 minus JI1X1, and also similarly the secondary induced EMF V2 is equal to V2 plus JI2X2. The reactance transfer, looking into the circuit from one source side to another source, here looking into the circuit from source side, let us define the primary. Let us define the primary impedances as X in is V1 by I1. Looking into the circuit from load side, neglecting the load itself, let us define the impedance XL leakage flux. This relating V1 by I1 in terms of Vs by S using the turns ratio A. So V1 by I1, that is equal to A square V2 by I2. X in is equal to A square into XL. Hence, in general, any impedance transferred from secondary side to primary side must be multiplied by the square of the turns ratio, that is a square. The leakage reactance of secondary refer to primary. X2 dash is equal to X2 by K square, that is equal to, here this is the turns ratio A square. A is nothing but N1 by N2, that is the turns ratio, N1 by N2. The total leakage reactance refer to primary. So X01 is equal to X1 plus X2 dash. Similarly, the leakage reactance of primary referred to secondary. X1 dash is equal to X1, that is X2 by I square. The total leakage reactance referred to secondary. The total leakage reactance referred to secondary is X02 is equal to X2 plus X1 dash. X02 is equal to X2 plus X1 dash. So here reactance is referred to secondary to primary. So this X2 is converted into X2 dash. X2 dash. So here X1 and X2 both are in phase, that is nothing but X01. So X01 is nothing but here the effective reactance in primary circuit. Effective reactance in primary circuit. So here X01 is equal to X1 plus X2 dash. X1 plus X2 dash. Here X2 dash is equal to the, in terms of turns ratio, it is A square into X2, or otherwise in terms of transformation ratio, that is X2 by K square. X2 by K square. The transformer with both winding resistance and leakage reactance. Here we are considered winding resistance and leakage reactance. This is the resistance and this is the reactance, and this at primary side and these are the at secondary sides. The primary side resistance is R1 and the leakage reactance is X1, and at secondary side the resistance is R2 and the leakage reactance is X2. So these are the primary side and these are the secondary side. The supply voltage, induced EMF N1 turns, N2 turns, and induced EMF at secondary side, and the load voltage V2 and current is I2, and here the primary current is I1. The main flux is the pi m. Here, by considering of these two, R1 and X1, R2 and X2, here Z1 is the nothing but the impedance at primary side, and Z2 is nothing but the impedance is at secondary side. The Z1 is nothing but R1 plus JX1 and Z2 is nothing but R2 plus JX2. So here resistance and leakage reactance of primary and secondary is drawn in this figure. So the impedance of the primary winding is, that is Z1 is equal to R1 plus JX1. Similarly, the impedance of the secondary is also Z2 is equal to R2 plus JX2. Therefore, the voltage drop in the primary winding is due to the resistance and leakage reactance. Here, once we can write here the loop equation at primary side and also the loop equation at secondary side. Here V1 is equal to E1 plus I1 into R1, I1 into R1 plus Jx1. So here R1 plus Jx1 is nothing but a Z1, that is the impedance at primary side, and here also you can write V1 is equal to E1 plus I1 Z1. In the similar way, at secondary side, the equation is E2 is equal to V2 plus I2 R2 plus Jx2. This I2 R2 plus Jx2 is the voltage drop at secondary side. Now we can write in this way V2 is equal to E2 minus I2 into Z2. This R0 one is R1 plus R2 dash, and R2 dash is nothing but R2 by K square, that is equal to A square. This is the turns ratio in terms of, this is the transformation ratio in terms of. So difference, and that is the difference. A is turns ratio, K is transformation ratio. The total reactance referred to primary side X01 is X1 plus X2 dash, and X2 dash is nothing but X2 by K square, that is equal to square into X2. The total impedance referred to primary, or so that is Z01 is equal to Z1 plus Z2 dash, and Z01 is equal to R01 plus JX01. The total resistance referred to secondary, where R0 is equal to R1 dash plus R2, where R1 dash is equal to K square into R1. The total reactance referred to secondary, where X02 is equal to X1 dash plus X2, X1 dash is equal to K square into X1. Total impedance is referred to primary, or Z02 is equal to Z1 dash plus Z2. Z02 is equal to R02 plus JX102. Here the summary is, we have discussed about how a real transformer with winding leakage is represented, the transformation of magnetic leakage into equivalent reactances, the derivation of the formulae to transfer reactance from one side to other side, the representation of real transformer with both resistance and leakage reactances. Next quiz. So the secondary load resistance X2 can be represented on the primary side is nothing but x2 by K square. This is the answer. When a transformer has a turns ratio 4:1, the resistance of HV winding 8 ohms and that of the LV winding is 1 ohms. The total resistance on HV side is, so here do the problem and we'll get the answer. Is the 24 ohms. And resistance of primary 2200 by 220 volts, 58 single phase transformer 4 ohms resistance when referred to secondary side will be. So this, which is the answer? This is the answer. A transformer has N1 and N2 turns in primary and secondary winding respectively. Its secondary winding resistance R2 when referred to primary is R2 by K square. That means R2 by R2 into N1 by N2 whole square. This is the answer. In a transformer, the resistance between primary and secondary is infinity. In a transformer, the resistance between primary and secondary is infinity. The frequently asked questions. These are the frequency asked questions. R1, R2, X1, X2 given, transformer ratio given, and it convert refer to primary side and then refer to secondary side. Equivalent resistance of primary and refer to secondary side. These are the frequently questions and derive the relation of equivalent impedance of a transformer when referred to primary side and referred to secondary side. And also sketches explain what are the effects of winding leakage of transformer and also necessity transforming impedances from one side to another side. These are the thank you.